You're welcome back to our physics class today. Today we are going to look at the equation of uniform accelerated motion, simply called the equation of motion. We have three equations of linear motion that we are going to derive today. This equation is going to help us solve any question on motion. So when we are able to derive these equations, we are going to then begin to apply it in questions. Any form of question that is linear motion, these equations that we're going to derive today will help us tackle it. But before we derive the equations, we need to know what every quantity in these equations represents. The quantities that are needed for the three equations of motion are going to be listed now. Number one is distance or displacement. Of course, as a quantity, distance is different from displacement, but in calculation we use them interchangeably. So distance and displacement is represented with S. In equation of motion, wherever you see S, it is distance or displacement. We have time represented with T. We have velocity, initial velocity, commonly represented with U. Final velocity, represented with V. Average velocity, represented with V bar. Then acceleration, represented with A, small letter A. So these quantities are the quantities we will see in equations of motion, some or all of them. So having known these quantities, S for distance or displacement, T for time, U for initial velocity, V for final velocity, V bar for average velocity, and A for acceleration, we are going to look at the three equations now. Starting with equation 1, from our definition of acceleration, we said that acceleration is change in velocity over time. And we know, I said that acceleration is represented with A. Change in velocity is difference in velocity. So when you have two velocities, the initial velocity and the final velocity, the change in this velocity is V minus U, the final velocity minus the initial velocity, divided by time T. So this is the first equation of motion, which can simply be written this way. You cross multiply, you have AT equals V minus U, and then can as well be written as V minus U equals AT. To make V the subject of the formula, V equals, when U crosses the sign of equality, minus U crosses the sign of equality, becomes U plus AT. So this is how we got the first equation of motion. From the definition of acceleration, we're able to get the first equation of motion. Okay, now if we move further, knowing this first equation, V equals U plus AT. Now to get the second equation of motion, we know that average of two things is the sum of these two things divided by 2. So if you have two velocities, the final velocity and the initial velocity, average velocity is the final velocity plus the initial velocity divided by 2. That is how you get average of two things. You sum them and divide by 2. So the average velocity is the initial velocity plus final velocity all over 2. We note this. Let's call this equation I. We also know that average velocity is total distance or total displacement, which is S over total time T. Let us call this I. So if we look at these two things, and then we have this equation 1, the first equation of motion. So these three equations are going to help us to to get the second equation of motion. Okay, if we say that average velocity is this or this, we can say that average velocity equals, okay, let's say substitute equation 1 in equation I. That is, carry this equation 1 anywhere you see v in equation I, replace it with u plus at. So it means that average velocity is going to be what? V plus u over 2. Instead of v is what? U plus at, then plus this u all over 2. We've not committed any crime. So average velocity becomes u plus u will give us 2u plus at all over 2. And we also said that average velocity is equal to s over 2. So have I done anything wrong if I carry this s over 2 to replace this average velocity? No, I don't think I've committed any crime. So instead of having average velocity equal to this, I can say instead of this average velocity, I'll have s over t is equal to 2u plus at over 2. You can see that because this is this, so I can use this to replace this to have this. Then when I cross multiply this one, I have 2s equals t times 2u plus at, and then I can open my bracket to have 2s equals t times 2u, you have 2ut, t times at, you have at squared, because t times t is t squared, then this a. Then if we divide both sides of the equation by 2, 2s over 2 equals 2ut over 2 plus at squared over 2. So that these two, we cancel these two, s will be equal to, these two will cancel these two, ut plus at squared over 2. And this over 2 means half of it. So s is equal to ut plus half at squared. And we have the second equation of motion. So the second equation of motion is s equals ut plus half at squared. So you can see that. Now we have two equations already. So if we go ahead to get the third equation, let me put the second one. Okay, the first one we have v equals u plus at, that is equation 1. The second equation we have ut plus half at squared, that is the second equation. Then let's get the third equation. I have already written that average velocity is final velocity plus initial velocity divided by 2. I have also written that acceleration is change in velocity over time. I have also written that average velocity is displacement, total displacement over time. So if we use these three, we get the third equation of motion. From our definition, average velocity is total displacement over time. When you see a question, you ask to find the average velocity. If you know the total displacement, all over total time, you divide it, you get your average velocity. If you know two velocities, the initial and final velocity, if you sum and divide by 2, it's still the average velocity. That is what that means. So, putting these equations together, if I use, let's call this one I, let's call this one II, and let's call this one III. So, taking equation III, if I cross multiply equation III, S is going to be average velocity times time. If you cross multiply these over 1, S times 1 is S, average velocity times time is average velocity times time. So we have this. Let me call this one equation IV. Then we are going to see something. In equation II, if I make T the subject of the formula in equation II, if I make T sort of formula, it means cross multiplying this so that I have AT equals V minus U. Divide both sides by A so that T becomes the subject of the formula. T will be equal to V minus U over A. So let me call this equation 5. V, equation V. So what we are going to do is, remember in equation IV, S is equal to average velocity times time. And average velocity is this, while time is this. So we are going to substitute. We are going to substitute equation I and V in IV. We substitute this and this into this. So we look at it that S equal to, what is our average velocity? That is V plus U over 2 times T. S is equal to average velocity times T, and T is V minus U over A. So you see this now. If we open our bracket, S is going to be V plus U times V minus U over 2 times A. You have 2A. So S is going to be equal to, when you see this difference of two squares, the difference between these two brackets is that this is plus and this is minus. And when you have that, you call it difference of two squares, because anywhere you see x squared minus y squared, that's difference of between one square and another square. It's the same as x plus y times x minus y. So I can write this as v squared minus u squared using this relation, all over 2a. This over 1. Then cross multiply. If I cross multiply, I will have v squared minus u squared times 1. You have v squared minus u squared equals s times 2a. You have 2as. Then if I move u minus u squared to the right hand side, v squared is going to be equal to u squared, because this negative will change to positive, plus 2as. And this is the third equation of motion. So you can see that. So this is our derivation: equation of motion 1, equation of motion 2, equation of motion 3. This is how we get it. So if we go further, we can actually get this third equation of motion using equation 1 instead of what we just did, if you would prefer that. If you come to equation 1 says v equals u plus at. If we say square this equation 1, we are going to have v squared equals u plus at squared. You know, whatever you do to the left hand side, you do to the right hand side of equation, you will not committed any crime. So if we do this, v squared will be equal to u plus at times another u plus at. So v squared is going to be equal to u times u. You have u squared. U times at, you have u at. At times u, you have another u at. Then 80 times 80, you have a squared t squared. So here we are going to have v squared equals u squared, because these two things are the same. If you add it, you have two of it, 2u at plus a squared t squared. Okay, see this thing now. This is what we want to get. You are using a different method now to solve it. So having seen this, okay, what I will do is v squared equals u squared. I have at the back of my mind I want to get 2as. If you look at these two things, what is common here? I can remove a from both. If you remove a from this, you will have 2ut left. If you remove a from this, because there are two a's, you have at squared left. Okay, so you can see what is happening here. We recall that s from the second equation is ut plus half at squared. So if we try to multiply through, to clear this fraction, we try to multiply through everything by 2. Multiply this s by 2, you have 2s. Multiply ut by 2, you have 2ut. Multiply this by 2, you have at squared by 2. The 2 will cancel this 2, you have plus at squared. Then if you look at this and look at this, you see that everything here is the same as everything in this bracket. 2ut plus 8t squared, 2ut plus 8t squared. So will I be wrong if I use 2s to replace this thing? I don't think I'm wrong. So I am going to now say, instead of this, I will have, because we have v squared equals u squared plus a, then everything inside this bracket will be replaced by 2s. So you have 2s, so that v squared equals u squared plus 2as, and this is another way we've been able to get the third equation of motion. So to get the first equation of motion, you use the definition of acceleration is change in velocity over time, direct. To get the second equation of motion, you use the formula for average velocity, the two formulas for average velocity, and then the formula for acceleration, that's equation 1. Then to get the third equation of motion, either you use the first method I solved, or this method. In this method, you use this first equation and the second equation to get the third equation. As simple as that. So we are going to look at probably 1 or 2 questions for today, and we will solve more questions in our next class. So you have this question. Suppose a bicycle accelerates at 1 meters per second squared from an initial velocity of 4 meters per second for 10 seconds. Calculate the distance covered. I always tell my students, in physics calculation, please list your parameters, list out the quantities that are there, so that you have idea of the kind of formula you are going to use to solve it. So if we, let's say solution, suppose the bicycle accelerates at 1 meters per second squared. That means acceleration A is 1 meters per second squared. From an initial velocity of 4 meters per second, the initial velocity is 4 meters per second. This can be written as 1 ms raised to power minus 2. This is the same as meters per second. This one can be written as 4 ms raised to power minus 1. Either this way or this way. If you are using minus, there will be no slash. If you are using slash, there will be no minus. So take note of that. So this is a quantity. Then we have for 10 seconds. Seconds is time. So time is 10 seconds. This is 10, this is second. Okay? So now what we usually do is that when you are in exam, when you want to answer this question, a question on motion, what you do is, as you have listed your parameters, try to remember the 3 equations of motion. V equals u plus at, v squared equals u squared plus 2as, then s equals ut plus half at squared. Whichever, the arrangement is not relevant. The most important thing is that you can remember the 3 of them. So if we have these quantities, you are asked to calculate the distance covered, and distance is s, is unknown. Remember I said distance and displacement, to represent it with s. So what you will do is to look at the quantities you have in the question and look at which formula contains all the quantities you have in the question. So you look at A, there is A here, there's A in the 3 of them. U, there is U in the 3 of them. T, there is no T in this one. So this one is out already. Then S, there is no S in this one. So this is the one we are going to use. So that means S is equal to UT plus half AT squared. As simple as that. One of the equations should be able to solve it. So if we look at that, it is the S we are looking for. So S is equal to, our initial velocity U is 4 meters per second times time is what? Okay, let me come here so that we'll see it clear. S is equal to 4 meters per second times time is 10 seconds times 10 seconds, then plus half times A. Our A is 1 meters per second square. So we have 1 meters per second square times time, which is 10 seconds. You also square 10 seconds because it's times time squared. So s will be equal to 4 times 10. You have 40 meters per second and second. In law of indices, if you say x raised to power minus 1 times x raised to power 1, that will be x raised to power minus 1 plus 1, which is x raised to power 0, and that is 1. So the s will go, that is 40 meters, plus half 1 meters per second times 10. 10 squared is 100. 100 times 1, you have 100 meters second per second square, and second square will go, so this is meters. So s is 40 meters plus 100 over 2 is 50 meters. So the distance is equal to 40 plus 50. You have 90 meters. So this is what we have. You can see that, but I can still solve it differently. So there is no particular pattern. One thing you see in equation of motion is that when you have the 3 equations, if you are able to identify the one that can solve it, good and fine. But even if you cannot, just as this one can solve it, these 2 can as well solve it together. If we use these 2 together, I'll get the same answer, or use this one. So what it means is that when I have a question, out of the 3, 1 will solve it. If you remove that one can solve it, the other 2 can as well solve it if you put it together. So let's look at how we're going to use the other 2 to solve it. In the first equation, v is equal to u plus 80. So how we put in the quantities I have, v is unknown, so I'll say v is equal to u. Initial velocity is 4 meters per second. So I'll write 4 meters per second plus acceleration is 1 meter per second squared. 1 meter per second squared times time is 10 seconds. So velocity is equal to, final velocity is equal to 4 meters per second plus 1 times 10 is 10 per second squared times per second times second. You have meters per second, because minus 2 plus 1 will give you minus 1. So this is what you have. So v is equal to going to be 4 plus 10, will give us 14 meters per second. So this is our final velocity. But you know, we are not looking for final velocity, we are looking for distance covered. Then use the other equation that was not the one we used. So I said if this can solve it, then these 2 can as well solve it put together. So having used the first one, let us use the second one. We say that v squared equals u squared plus 2as. And our v is 14 meters per second. So we're going to say 14 meters per second raised to power 2 is equal to u is 4 meters per second raised to power 2 plus 2 times acceleration is 1 meters per second square. 1 meters per second square, sorry, about the small times distance, which is